Okay? So you need to try. No, no, no. Go up. Up, 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 all the way to the top. Go to important information. Nope, right there. The first one. Then go down to October 22nd. Yep. And it says Subaru dataset. Mm-hmm. All right. So I want you to kind of put together some graphs. Is this module 8? It's so dark. How can you see that? Go here. This one right here. All links and stuff. And then go way down to find October 22nd. Jesse, come on, put that away. October 22nd. Subaru link. So everybody finding it? Did you find it? Find it? Where's your computer?
Right.
Yep. It's dead at home?
Yeah, I forgot it.
Well, bring it dead here and we can at least...
No, I had it. Well, it's probably charged now, but I had it like on my bed, but my bug's going to leave me.
Oh, yeah.
So I ran out.
Okay, so you need to make some graphs and we want to look at these graphs, okay? Because they are of the same vehicle. All right? So, as it guides you through this, okay, says make appropriate graphs that would allow you to see if there's a relationship between price and age and price and mileage. Describe the direction, strength, and form of the relationships you observe. Does either mileage of age, or age seem to be a good predictor of price? So, all right, taking a look at my graphs. Let's see if I can pull this down and pull this up. And let's see if I can make this a little bigger. Okay. Here we go. So, what can you tell me about looking at this first graph? I'm going to minimize this one. On the front, what can you tell me about the price of used Subarus in general? What can you tell me about the price of used Subarus? The more expensive they are, they have what in mileage? Yeah, they have less mileage, right? So the less mileage you have, the more expensive it's going to be. That seems to make sense, right? Or the more miles you have, the less the cost of the Subaru, right? So let's go over now and let's click on the ruler. Let's do a count. Did they say 20 or 22? Oh, did they say 22? Okay. Let's just check some of these out. Let's see what connecting lines does. Sometimes you just have to be on here and play with things. Ooh, is that very helpful to us? No, that looks like a 3-year-old got to it or something. So let's take that off. Movable point. Ooh. So that gives you a point. Supposedly it's movable. Let's see. Does yours move? Oh, there we go. So this gives you an additional, what if I had this? What if I had this? Okay. All right. So maybe that's interesting. Do you think that's helpful to us now? No, probably not. Let's go to a movable line. Movable line. Okay. So if you had to do what we call the line of best fit, meaning you are going to change this line so it actually resembles the majority of where all these dots are, okay? You can move this around. So try moving it around. Now, I do not want it to go in a positive slope because this particular graph for me is not that way. So you pick on one of the others and you can kind of move it around, okay? And you want to pick, like I said, where you think it best resembles line of best fit, where it best resembles all of your data, okay? So for me, do you see and do you have that little equation? Do you see the little yellow mark equation? Riley, are you with us? Okay, so it says, this equation says price is equal to negative 0.142 dollars per mile, times the mileage, I'm running out of space, times the mileage itself, plus $25,488. Now, what does this equation represent? In other words, what formula that you are aware of from your past mathematical history or academia does this maybe resemble? So this is a line, right? This line of best fit that I manipulated around. What is the formula for finding the graph of a line? If you had a line and you had to come up with a formula for that line, what formula would you use? Would you not use y equals mx plus b? Hello? Yes, you would. I don't like how this is so skinny. Y equals mx plus b. So the price, in trying to find the price, you would take negative, this is your slope right here, it's negative. You would take that negative number times your mileage and add this b part, okay? That b, if I can drag it down, is where it is the y-intercept, right? So right here, this is the y-intercept. All right, so did everybody pick a line they think is the line of best fit? Now, I want you to go back to that ruler, and I want you to click on least squares line. Okay, do you see? It should be a different line. You should have two lines there. Do you see that? Yes, no, maybe. Do you see there are two lines? Hopefully, your two lines are very close to one another, okay? If they are, that means you really did a pretty good job of picking the actual line of best fit, all right? So what they're saying for this data, I'm moving this up here, I was pretty close, but the correct answer is this formula, all right? Now, they also have what we call R squared, okay? That is the strength of this correlation, the strength, okay? I think I'm going to get back into that tomorrow because I want to be more certain with that. But, so you came up with a line of best fit, and then you should have gone to the other one. This is what we would actually use, okay? Which is that second one, and what did they call it again? Least squares line. All right, I'm going to try to get rid of all this over here now. And let's go to show fit uncertainty. Show fit uncertainty. So it talks about the slope, the intercept. I think that's a new feature because I don't even remember that. All right. Squares of residuals. I don't think we need to know that either. All right. But this would be able to help Jane if she was going to try and figure out an appropriate price. I forget, is she buying or she's trying to sell? She's trying to sell. So she's trying to figure out what is the price that she wants to put out there. She would use this slope, negative 0.133. She would put her mileage there and then add 24,200, whatever that is. Okay. Now, let's take a look at the other graph. The other graph. How much time do I have? Okay, so let's take a look at the other graph really quickly. So this is similar, but this uses age, price and age, not mileage. Okay, so again, go to that ruler. There should be 22 different things there. Go to movable line. Move your line for this one. Okay. Manipulate it if you can. Mine's being a little temperamental. Okay. And again, we still see the higher the cost, the younger in age that your vehicle is. Okay. I'm trying to find, that looks to me like it's maybe kind of in the middle. Okay, now I'm going to add my least squares line. Oh, I just lost it. Undo, where's undo? Did you? See? Cool. All right, come on. Least squares line. Ooh, I wasn't as close. Okay. So here, the price, she could find a price by putting in the age. So, does it say how old her Subaru is in the problem? No? Does it say what her mileage is? It doesn't say either? Okay. Make appropriate graphs that would allow you to see if there is a relationship between price and age, between price and mileage. Describe the direction, strength, and form of the relationships you observe. Does either mileage or age seem to be a good predictor of price? Well, they both are, okay? But we need to get in a little bit more of this, okay? Do not exit out of this. So have this, I mean, you can close your notebook and stuff, but maybe just leave that up, or we can bring it up tomorrow too. Just remember how you can bring these up. Oh, not tomorrow. Friday. Friday. What? I don't think we're supposed to. Yeah. So you just do whatever you're supposed to do for the school, your job shadow, your visit the college, whatever kind of thing with that. Okay? All right. Hey, we are getting closer to when we are going to need to know all this stuff for your project. So we'll finish this up some on Friday.